the term is momentum. Okay. So what do you know about momentum? Have you heard this term before anywhere in English or in any other subject or in physics?
Ye- Yes, ma'am.
Okay. So what is the meaning of the term momentum?
I don't know.
Any idea?
Mm,
What do you think when look at this word
like
and when you read this
I have
word,
heard
what comes in
momentum
your
word
mind
in
first? Hmm?
I have heard momentum word in cricket when like cricket when players
Yes,
like
ma'am, I have also.
say that now now the momentum will be um
Okay.
like when a batsman get out, now they said that the momentum of the team is will be like slow down.
Hmm. So in physics, momentum means the quantity of motion. See, we are doing mechanics, right? So in mechanics, it deals with the motion of objects. It deals with the speed, acceleration, force, and other quantities like this, which are responsible for the motion of any object. So momentum is the quantity of motion contained in an object. Quantity of motion means, see, with what velocity the object is moving, right? How fast or how slow the object is moving. So if we say that if an object is moving faster, then it might have greater momentum, or if the object is moving slower, then it might have, less momentum. So it is the quantity of motion. But there are two factors which are responsible for this. One is the velocity that I have discussed already, that yes, more velocity, more momentum, less velocity, less momentum. And second is the mass. Mass is also, connected with this. And how is mass connected with the quantity of motion? Any idea?
Mm, no, ma'am.
See, if I take the same example that we have taken in a previous class, that if we have a hill and one rock is sliding down the hill, and we have one stone, very very small stone, that stone is also sliding down. And if you want to stop the rock or the stone, then we find, stone is easier to stop as compared to rock, no?
Yes, ma'am.
So why is stone easier to stop, and why do we face
Because
difficulty in stopping the rock?
because the rock is a rock
Because
has a larger mass than a stone.
Hmm. Because rock has larger
because
mass and more mass, more inertia, so its ability to stay in its state of motion is greater as compared to stone, right? And this is the reason that stone is easier to stop and rock is difficult to stop. So momentum consists of, here we have two quantities, mass and velocity. So momentum depends upon these two quantities, both the mass and velocity. So if the object is moving faster, then it has greater momentum, and more massive objects have more momentum. If the object is massive, then it has more momentum in it. If it has less mass, then it has less momentum. Okay, so let's just take this topic today. Write the heading in your notebook: momentum.
Yeah, I'm written.
Great. See, momentum is denoted by the small letter P. Dynamics is also again the branch of mechanics. Here we talk about the two things. First, we talk about the motion of any object that we had discussed already in motion chapter. And second, we talk about the cause producing motion of the object. What is the cause which is producing the motion in an object? Why is the object moving? Why has the object come to, rest? Are you getting what I'm saying? We also discuss, we have the question why here. Why is this thing moving? Why is the velocity changing? Because the velocity is changing because there is certain kind of force acting on it, and therefore its velocity is changing. Because without force, no velocity, we do not see change in velocity, right? So in dynamics, we talk about both the motion and the cause producing motion. Cause producing motion is always force, right? Because without the application of force, we cannot see the change in the state of motion of any object. Even if we say that, yes, we have kicked the ball and ball rolls on the floor and it stops after some time, there is a force acting on it, like frictional forces are acting on it, right? And if we talk about other things, that we have thrown certain thing from a certain height, and it is flying and just moving here and there. Then there also we have air friction acting on the object, and air friction is responsible for the change in the velocity of the object. But apart from air friction, there is gravitational force as well, which is responsible for the change in velocity, right? So there are kinds of forces acting on the object which change the velocity of any object. Without the force, application of force, we cannot see the change in velocity. And these experiments, the experiment done by Galileo and Aristotle fallacy that we had discussed in the previous classes. So we know about this now, right? And Newton's first law also states the same thing, that every object, continues to be in its state of rest or of uniform motion along a straight line unless or until compelled by some external force to change the state. I hope you are learning everything what I have speaking here, because this chapter is a part of your curriculum in New Zealand as well, right? So you are doing the same chapter there also. If you find something that is covered in your class and we are not covering here, you can discuss, we can share that topic, we can discuss that topic in the class itself. Okay. So momentum, the motion of a body, is represented by two physical quantities in dynamics. Motion of an object means if the object is moving, then we talk about two physical quantities. In dynamics, we have discussed already, where we discuss force, right? One is momentum and other is kinetic energy. Means the quantity of motion it carries is momentum, and kinetic energy is the speed. Oh, it is half mv square. Kinetic energy is the energy possessed by an object by virtue of its motion. So if an object is moving, then we say that it has some kinetic energy in it. So when two stones of different masses drop from the same height on a vehicle, which will cause greater damage? The larger stone?
Larger one.
Why?
Because it's heavy and its mass is greater and it has more inertia.
Yes, its mass is greater, and the one which has greater mass has greater momentum. Because momentum is directly proportional to the mass of the object. So if we have two different stones and they are dropped from the same height and they are of different masses, then the one with greater mass will cause greater damage because it has more momentum in it, right? So since the larger stone with greater mass applies greater force, even though both stones have the same velocity when they touch the ground, right? Because it has greater mass and therefore it can apply greater force on the object, no, on which it is falling. If two stones of same mass from different heights dropped on a vehicle, which one will cause greater damage? Now we have stones of same mass. Initially, in the previous question, we had stones of different masses and they were thrown from the same height. No, we had dropped the two stones of same mass, different masses from the same height in the first question. Now in the second question, we are keeping the mass same, but heights are different.
I think that one who is from that has been dropped from a higher height.
Yes, the one which is dropped from a greater height will cause greater damage. Why?
Because it can catch speed after some time faster than the smaller one.
Yes, the stone falling from the greater height produces greater damage because it has more potential energy associated with it, because the one which is placed at greater height has greater potential energy, and when it is dropped from that height, the whole potential energy gets converted into the kinetic energy of the object. So the kinetic energy goes to the mass. No? Because the stone falling from a greater height will have larger velocity. Why larger velocity? I had told you that if we are keeping two stones at different heights, we are keeping two stones at different height, then the one which is placed at greater height has more potential energy in it, because potential energy is mgh. It is directly proportional to height. So if we have placed any object at greater height, then it has more potential energy in it, and when it is dropped from that height, the potential energy it carries, the whole potential energy it carries, gets converted into kinetic energy of the object, if we consider that there are no dissipative forces or energy losses are occurring. And therefore the one which is placed at greater height will have larger velocity. When it is dropped from that height, it will have larger velocity, and because it has larger velocity, then it will because of large velocity, it applies greater force. ठीक है, because its momentum is greater and hence it applies greater force and therefore it will cause greater damage. Now you understood? See, in the previous
Yes, ma'am.
question, what was the question? Previously, we had this question.
That same height but different mass.
Yes, we had kept the height same, but masses were different. So when masses were different and we had kept the height same, because height was same and therefore velocities were equal. Speeds were equal, velocities were equal. And masses were different. And because of the difference in mass, impact was different. The greater mass had greater impact, right? And now we are keeping the mass same, but we are changing the heights. Because we are changing the heights and therefore velocities are changing, and because of the change in velocity, you can see the one which is falling faster will produce greater damage. So momentum is proportional to both mass and velocity of the object, right? So if two stones of different masses are dropped from different heights on a vehicle, which causes more damage? Rushil, where's the charger? Dena beta charger.
A heavier stone with a heavier mass and larger height.
If two stones of different masses are dropped from different heights. Now we have different masses, stones of different masses and heights are also different. Both the quantities
Yes,
are
ma'am. A larger mass and a larger height will cause more cause.
greater mass and greater height. Okay. It's not working.
Yes.
The stones of larger mass dropped from greater height causes greater damage because the product of mass and velocity is larger in this case we're taking. Lavash, please turn on your camera. So momentum of a body is defined as the quantity of motion contained in it, and it is measured as the product of mass and velocity. It is denoted by a small letter p. This we have discussed already. So if mass of the body we're taking as m and velocity we're taking as v, then momentum is p m into v. Okay, please write this. Everything you are supposed to write, whatever is there on the slide.
Okay, ma'am.
Because momentum is mass into velocity, we are multiplying these two quantities to get momentum. So in CGS system, its unit is gram centimeter per second. Because in CGS system, CGS, C for centimeter, G for gram, S for second. We take length in centimeter and mass in grams and time in seconds, and therefore the unit is gram centimeter per second in CGS system. While in SI system, the unit is kilogram meter per second. We take mass in kilogram and velocity in meter per second, right? So dimensional formula, though it is not the part of your syllabus, but because we have mass and kilogram, for mass we write m because kilogram is the unit of mass, and for length we write L, for time we write T. So mass, length and time, MLT. Okay? Mass, length, time, MLT. So T minus 1, you can see that we have a power here, -1. Because per second we have, in the unit you can see it is per second. Na? In the same way we have written in the dimensional formula T minus 1. And momentum is a vector quantity whose direction is in the direction of velocity, because momentum is mass into velocity. Are you finding this chapter difficult or boring?
No, ma'am.
Mass is a scalar quantity and velocity is a vector quantity. So we are multiplying a scalar quantity to a vector quantity and we are getting another vector quantity, momentum. Okay. And you can see the arrows over P and V. These arrows you can see. Can you see that in the formula?
Yes, ma'am.
That represents vector. Those arrows represent vector. So momentum is a vector quantity and the direction of momentum is same as that of velocity. Okay. Please write this down. Okay. From question number 5 to question number 13, these questions are based on momentum. You can see the heading is momentum. The first question is question number 5 for momentum. It is what is the momentum of a 100-gram ball? So mass is 100 gram. So first we need to convert this 100 gram into kilogram, because gram is the CGS unit. It is not the SI unit. And velocity is given. Velocity is in meter per second. Velocity is in meter per second. So velocity is in SI unit and gram is in CGS unit. So it doesn't make sense. No, these belong to different units, system of units, right? We have two different system of units here. One is CGS, other is SI. So we need to convert this also in SI system of units. So in SI system, mass is measured in kilogram. So 100 gram is 100 upon 1000 kilogram. Zeros will get cancelled and we are left with 1 upon 10. 1 upon 10 is 0.1 kg. So mass is given and velocity is 5 meter per second. You are asked to find momentum. How do we find momentum? Momentum is mass velocity, right? Just put the values. Mass is 0.1, velocity is 5. So momentum is 0.5 and the unit of momentum is, in SI system, it is kilogram meter per second. Just write the units of both mass and velocity together and the unit of momentum, you get the unit of momentum this way. First write for mass and then for velocity. It's kilogram meter per second for momentum. So 0.5 kilogram meter per second. Clear?
Yes. Yes.
Okay. In question number 6, again, we have,
Can we take the screenshot?
you are supposed to write this. First write this.